This is USMLE QA, USMLE material presented in a question and answer format structured similar to the first aid for the USMLE Step 1 book.
Question: what is the degree of change in mutations in DNA? Answer: the degree of change in mutations in DNA is silent, lesser than missense, lesser than nonsense, lesser than frameshift. Question: how are single nucleotide substitutions repaired in DNA? Answer: single nucleotide substitutions are repaired by DNA polymerase and DNA ligase. Question: what are the two types of single nucleotide mutations? Answer: the types of single nucleotide mutations are transition, purine to purine or pyrimidine to pyrimidine, and transversion, purine to pyrimidine or pyrimidine to purine. Question: can you give an example of a transition mutation? Answer: an example of a transition mutation would be a change from an adenine to a guanine base in DNA. Question: can you give an example of a transversion mutation? Answer: an example of a transversion mutation would be a change from a cytosine to a thymine base in DNA. Question: what is the difference between transition and transversion mutations? Answer: transition mutations are changes from a purine to another purine or from a pyrimidine to another pyrimidine, whereas transversion mutations are changes from a purine to a pyrimidine or vice versa. Question: what are the effects of frameshift mutations? Answer: frameshift mutations occur when a base is inserted or deleted from the DNA sequence, resulting in a shift in the reading frame. This can lead to the production of abnormal or non-functional proteins, which can result in disease or death. Question: how do frameshift mutations differ from other types of mutations? Answer: frameshift mutations differ from other types of mutations in that they change the reading frame of the DNA sequence. Other types of mutations, such as silent, missense, and nonsense mutations, do not change the reading frame and may have less drastic effects on the function of the resulting protein. Question: what is the impact of point mutations on protein function? Answer: point mutations, particularly missense and nonsense mutations, can greatly impact the function of the resulting protein. Missense mutations change a single amino acid in the protein, which can disrupt its structure and function. Nonsense mutations introduce a premature stop codon, resulting in a truncated protein that may not function at all. Question: what are the different types of point mutations? Answer: the different types of point mutations are silent, missense, nonsense, and frameshift mutations. Silent mutations do not change the amino acid sequence. Missense mutations change a single amino acid in the protein. Nonsense mutations result in a truncated protein, and frameshift mutations change the reading frame of the DNA sequence. Question: can you explain what happens during a transition mutation? Answer: a transition mutation is a change from a purine to another purine or from a pyrimidine to another pyrimidine. For example, a transition mutation would be change of adenine to guanine or cytosine to thymine base in DNA. This type of mutation doesn't change the amino acid, thus it is less likely to affect the protein function.
Thank you for watching our Q&A format video. We hope this helped you learn, review, and retain knowledge needed for the USMLEs. For more information on this topic, check out the link in the description. Now, if you want to take your USMLE prep to the next level, be sure to check out all our courses, which are structured to follow along with the first aid for the USMLE Step 1 book. You can find us at usmleqa.com. And if you're watching this on YouTube, be sure to like and subscribe.